started on analytical geometry. Emilio, no. No, all right. I'm going to show you guys the drawing, and I'm going to show you guys the questions. And you guys can do them together. We're all going to do 2.1 and 2.2. So I'll give you a chance to look at 2.1 and 2.2. Remember, guys, read the information that you've been given up there. Look at the questions and make sure that they are corresponding. Let me do this. Okay. I feel like I'm being a bit idiotic. Let me do this. Okay, take this one and move it over here. There we go. Okay, this one's first, and then that one. All right, there are the questions and the drawing. Okay, I'm going to give you guys, let's see, 17 marks. So I'm going to give you guys 10 minutes to get through this question. Go ahead and do it. Once you're done, as always, pop your answer, pop your favorite emoji in the chat. If there is a question that you're struggling with, please just skip it and keep going. All right, and then we'll have a chat after 10 minutes. All right. Cheers, everyone. 10 minutes. I'm sorry, Samuel. Emilio, you crack me up. Right, so far I've got exactly 2 emojis. So I'm gonna wonder where everyone else is. I hope you guys are slowly chipping away at the questions. Okay. Yes, Amber, I was hoping we'd do everything. But like I said, if there's a question that you're not quite sure of, you can skip it. We will go through it in a bit more detail in a bit. Yeah. I'll give you guys 2 more minutes, regardless of where you are. We're going to start looking at the answers. Yeah. Nice emoji, Samuel. It's the first time I've seen such an emoji. I like it. One more minute. Funzo, you are correct. Yes, 100% correct.
It's on YouTube now.
All right, peeps, let's get into some of these answers. Okay, so first thing we're always going to do is we're going to read the information that they've given us to make sure that we actually get the correct answers. Okay, make sure that everything that they've written over here, up top here, is actually in the drawing so that we don't miss anything. All right, so they say in the diagram below, P, which is 1, 0, and Q, which is 6, 3, and R, which is 9 and negative 2, are the vertices of a triangle such that PQ is equal to QR. Now, there's some information they haven't actually put on the drawing. So I know that the length of PQ is the same as the length of QR. So that one and that one, same length, right? PQ is perpendicular to QR, which is great because then that tells us that PQR is a right-angled triangle and we can use certain other formulae if we need them. Okay, then it says T is a point on PQ such that T is the midpoint of PQ. So we know that T is the midpoint, right? Does that necessarily mean, that S is also a midpoint of QR? Is that what we're saying? Is that correct? Yes or no? No. Okay, we cannot assume that, we will not assume that, we're not going to make that kind of assumption. We are only going to work with the information they've given us. So we're not going to make that assumption. All right. Okay, S is the point of intersection of RQ, good, and the x-axis. Now we know that if this is on the x-axis, that means it's an x-intercept. That means our y-coordinate is automatically going to be 0. The thing that we don't know is the x-coordinate. All right, V is a point on the x-axis such that QSV is 121 degrees and QPS, this one over here, is theta. All right, let's start with the first question. It says, determine the length of PQ. Now, I know I'm going to use my distance formula, so I know that PQ must equal to the square root of x1 plus x2. Teacher Coco, the lies. Okay, x2 minus x1 all squared plus y2 minus y1 all squared. Right, so PQ will then equal to, now it doesn't matter which coordinates of P or Q you name what, it won't make a difference. I'm going to name these x2 and y2 and that one x1 and y1. Okay, so x2 and x2 and y2, this one x1 and y1. So I will then have 6 minus 1 all squared plus, open brackets, 3 minus 0 all squared. Okay, therefore PQ is going to equal to the square root of 34. Now we need to leave it as the square root of 34 because the question tells us to leave the answer in surd form. So we're going to leave it. Okay. All right, we're going to leave it right there. Okay, cool. So that's 2.1.1. Okay, they're not going to give you a lot of marks, one for substituting into the correct formula, one for the final answer. Right, 2.1.2 says the gradient of PQ, we can do that. The gradient of PQ, I've already named them. I know that the gradient is going to be y2 minus y1 over x2 minus x1. Right, now I know y2 is going to be 3 over 0 over 3 minus 0 over 6 minus 1, and that's going to give us 3 over 5. Thank you, Funzo. 100%. All right, again, 1 mark for substituting, 1 mark for the final answer. Right, 2.1.2. All right, 2.1.3 says they want the coordinates of T. Now they've already told us that T is the midpoint of PQ. So we know we're looking for the midpoint of PQ. Open bracket, x1 plus x2 over 2 and y1 plus y2 over 2 will give us the coordinates of the midpoint. That's going to tell me that the midpoint of PQ is going to be 6 plus 1 over 2 and 3 plus 0 over 2. Okay, that's going to give me the midpoint, or in fact, it's not the midpoint of PQ anymore, it's the point T, correct. T is going to give us 7 over 2 or 3 over 2, one of the two. Okay, Funzo, I don't know where we got 4 from. Double check again. Thank you, Amber. That is indeed correct. Funzo, just double check your x coordinate. Okay, it's 6 plus 1, which should give us 7 over 2. All right, 7 over 2. Okay, excellent. All right, next question says calculate the area of QTR. Now, if we want to calculate the area of any shape, what do we need? What is the thing that we need? Not quite, Amber. Let's say, for instance, correct. That's it, Mirula. Good. I was about to say, let's say, for instance, they gave you a triangle that wasn't on the Cartesian plane. We would need the lengths of each side in order to calculate for the area. And we know that the area of a triangle is half base multiplied by the height. Now they want the area of triangle QTR. Let's map that out. QTR. Right, that one there, like that. So in this case, we already know the length of QR. What is the length of QR, peeps? You can tell me? What is the length of QR? We don't even have to calculate it. We just know what it is. What is it? Anybody got any idea? Think about all the information we have. I'll give you guys a hint. I'll give you guys a hint. We know the length of PQ. Correct, Anna. Beautiful. The length of QR, which is this side over here, the length of this side is also root 34. Right? Because in the write-up, they told us that PQ and QR are equal. They told us that they are equal, right? They are equal. So if PQ is equal to root 34, QR is also equal to root 34. Now, here's the next question. What is the length of QT? Something else we don't need to calculate. What is the length of QT? Who's got any idea? Okay, I'll give you another point. I'll give you another hint. I'll give you another hint. We know that T is the what? What is T? What is T? Correct, it's the midpoint. It's the midpoint of the line PQ. Now, if we know that PQ is root 34, what is QT going to be? Not the same, not quite the same. Correct, yes, Anna, correct. It will be half of PQ, half of it, which is just the square root of 34 divided by 2. That's all, it's half. All right, so now we can calculate for the area of our triangle, right? So I'm gonna have a half, my base is QT, so a half of root 34 over 2 multiplied by root 34. All right, and we're not gonna be fancy about it. You're just gonna pick up a calculator, put the answer in. Okay, find me an answer, please, guys. Pop your answers in the chat. Give it to me in... No, Amber. Check again. Check again. It's too small. Check again. Give it to me as a fraction, please, guys, when you do find your answer. Double check, please, Amber. Remember, it's just basic. Oh, no. Correct. Funzo's got the correct answer. That's it, Bonolo. Well done. Good. If you punch that into our calculator, we're going to get 17 over 2. And somebody reminded me that we must do units squared. Because it's an area, we must get the units squared part of it in there. All right. Okay. Now, 2.2.2 says they want the size of the angle theta with reasons. With reasons. And the only time they ever ask us for reasons is when we're doing geometry. So it's a geometry question. Okay, pop your answers for the size of theta if you've got an answer for me. What is the size of theta? Who has figured it out? Okay, I'll give you guys another hint. All right. Most questions, not 90, oh no, okay, most questions will not give us information for nothing. Correct, Lufuno. Good, that's the correct answer. Right, they won't give us information just for mahala for vibes. Okay, so the reason that they've told us that this part over here is 121 degrees means that it has something to do with theta. It has something to do with theta. Now, I'm going to show you guys that we can use this triangle, PQS. Look at triangle PQS. In terms of triangle PQS, what do we know about 121? What can we claim 121 degrees to be? A what? What kind of angle is 121 in relation to triangle PQS? Yes. Funzo's like an X what? Correct. It's an exterior angle. Good, Bonolo. And what do we know about exterior angles of a triangle? That they're equal to what? Oh, no, they're not equal to 360. They're not equal to 180. Okay. Now we have to go and search our minds. This is grade 7, grade 8 geometry, not 90. Yes, Pascal, correct. The okay, the exterior angle is equal to the sum of the opposite interior angles. So this angle plus that one must equal 121. That is what the mathematical, the geometric rule says. So I can then say theta plus 90 degrees is equal to 121 degrees. And my reason is exterior angle of a triangle is equal to the sum of the interior opposite angles. Okay. Then we can calculate for theta. Give me an answer for theta in the chat. Theta is equal to what? Correct. There we go. That's an easy solve. Theta will be equal to 31 degrees. All right. Give me a thumbs up. Are we all okay with how ma'am explained 2.2.2? Are we all okay with that? I don't think it's that difficult a concept. Okay. That's it, Anna. That's all we had to do. Yes, 121 minus 90 will give us 31. Okay, let's talk about 2.2.3. Right. The coordinates of S. Now, we know that S lies on the x-axis, and that automatically means that the y-coordinate is 0. So how are we going to, which equation or what formula are we going to use in order to find the x-coordinate for S? Who's got an idea for me? I'm just going to erase this one here. I'm going to put 2.2.3 here. Which formula do we want to use for this one? Dual intercept? Not quite, because the way we would use the dual intercept method is if they've given us the equation and we want to draw the line. So that's not going to help us here. They've given us a line. How does the line then translate to S? Okay, let me ask a different question. Q and S and R are all points on the same line. What do we call points that are all on the same line in analytical geometry or in general? What are they called? Another hint, it starts with co. Co something. And I was like, yo way. Co something. It's not co-interior. It's not corresponding. Teacher nows don't start. It's not Coco. It's not corresponding. Yes, Cassidy. Beautiful. They are collinear. Correct. Teacher Nelly, please. They are called Coco lines. Yes. They are called Coco lines. I love them. Coco lines. I'm kidding. Okay, they're not called Coco lines. They're called collinear, right? Which means if I can find the equation of the straight line QR, that equation of the straight line is also going to include S. And then if I want to find the x-intercept, I'm just going to go to that equation of the straight line and I'm going to make y equals 0 and I can solve for x. Okay, so first thing I'm going to do is I'm going to find the equation of the straight line QR. So I'm going to start by looking for my gradient first. So I'm going to go, the gradient is equal to x1, y1, x2, y2. All right, so my gradient is going to equal -2 minus 3 over 9 minus 6. Okay, Pascal, I'll explain to you because there's more than one way to do it, but I will show you just now. All right. Okay, that's going to give me, the top is going to give me -5 and the bottom is going to give me 3. All right, so -5 over 3. All right. Okay, that's the gradient. I'm then going to use the formula for the equation of a straight line that we get in analytical geometry, which says y minus y1 is equal to the gradient multiplied by x minus x1. Okay. Okay, so I'm going to then pick a point on the line. I'm going to use QR because I like positive numbers. I'm going to use the point Q. So I'm going to use 6, 3, and I'm going to sub it into Y1 and X1. Right, so I'm going to get Y minus 3 is equal to negative 5 over 3, open brackets, X minus 6. Right, and then we can multiply out. Y minus 3. That's fine. You're more than welcome to do that, Funzo. You can use that. All right. Y minus 3 is equal to negative 5 over 3x. And we did. Anna is so correct. We didn't have to find the gradient because we know that this is 90 degrees. So we could have just used the gradient of the other line and just use the reciprocal. Oh, thank you, Anna. I didn't notice until you said something. Minus 10. Oh, plus 10. A negative and a negative will give us plus 10. All right. Then the negative 3 will come over and become positive. So the equation of the line is going to be y is equal to negative 5 over 3x plus 13. Right. That's the equation of my line. Now, if I want to find the x coordinate of the s over here, I'm just going to make my y value 0. And then I'm going to solve for x. So I'm going to go over here. 0 is equal to negative 5 over 3x plus 13. And then we're going to solve for x. Please solve for x for me, guys, and tell me what x is equal to. Therefore, x is equal to something. I'll wait for you guys. I'm lazy. I'm going to wait for you guys to find me the answer. Okay, in the meantime, Anna, we're going to take this formula that we have down here. And because we know that S is the x coordinate, sorry, not the x coordinate, the x-intercept. This is the x-intercept. What do we know about the y value when we're looking for the x-intercept? X-intercept, y equals what? Y would be equal to 0, correct. So if you look over here, I have taken this y value and I've replaced it with 0, and we're now solving for x. Okay, I hope I'm making sense. All right, in the meantime, Pascal, what you could have done, if you chose to do the 180 minus, you could do this. We could say that PQS is still a triangle. You're correct, PQS is still a triangle. Now, we could find this angle. We could go ahead and look for that angle, which in that case would mean 180 degrees minus 121, which is angles on a straight line. So we could easily do that, and we're going to get 59 over here. We'll get 59 degrees. Then we can treat Q and S and P as not vert op. Then we would use the interior angles of a triangle. The sum of the interior angles of a triangle. Vertically opposite wouldn't work here because the only two angles that would be vertically opposite would be this one and that one. All we're saying then is that this one is also 59 degrees. That didn't help us in any way. Okay, we need to use either the exterior angle of a triangle or the interior angles of a triangle, one of the two. All right. Okay, good stuff. All right, Funzo's got an answer for x for me. Funzo says that the answer is 7,8 as a fraction. Guys, I agree with Funzo. Actually, I do. Let me just see. Negative 13 divided by negative 5 over 3. Yes, negative 5 over 3 is equal to no. Yeah, negative 13. I get something different. I get 39 over 5. X is equal to 39 over 5. Okay, do not. Because if you, the thing with converting to decimals, Anna, is that you're going to round off. Okay, we don't want to round off. So leave it as a fraction. All right, so the coordinates for S, as the question says, the coordinates for S is going to be 39 over 5 and 0. That's the answer we will write in our book. S is 39 over 5 and 0. That's what we'll write in our answer book. All right. Okay, let's look at the last one over here. Okay, which is a little bit trickier. Let's look at 2.3. Okay. Now, 2.3 says here, determine with reasons the gradient of the line through T and the midpoint of PR. So what they actually want, okay, is the gradient of the line through T. So T is going to be one of the collinear points and the midpoint of PR. So we need to go to PR and we need to find the midpoint. So what we actually want is the gradient of the line that would go like that. That's what they're asking for. Okay, so what's the first thing we're going to look for, guys? In this case, it's okay, Pascal. It's just in the way that it's worded. I'll be honest. It is a weird word. The way that they've worded it, you need to know exactly what it is you're looking for. Okay, Cassidy, remember, in order to calculate a gradient, we need two points. At the moment, we've got 7/2 and we've got 3/2. What are we missing? Ah, Anna, don't be this person. Don't be this person. Okay, we need 2 points in order to find the gradient. So the first thing we need to do is go look for the midpoint. Okay, correct. We need to go look for this midpoint here. And we can do that because we can just use the midpoint formula. It's not even that difficult. All right, so find me the midpoint M of PR, please, guys. Pop your answers in the chat once you found that for me. Find me the midpoint of PR. Okay, Funzo says -4 and 1. I just need a few other people to confirm. Let's just see if that's the exact answer that I'm looking for. Okay, Anna got the same. Okay, so midpoint of PQ. Give me 1 plus 9. Aibo. 1 plus 9. Guys, are we sure? I'm already at 1 plus 9. 1 plus 9 over 2. And the other one is 0 minus 2. Yeah. Amber, 0 minus 2 over 2. I know. Okay, which is the midpoint of PQ should give me 1 plus 9 is 10 divided by 2 is 5. I have a feeling that Anna and Funzo minused instead of plussing. 5 and -1. That's the midpoint. So this point over here is now 5 and -1. Yes, Funzo. But ma'am, okay. With that being said, we can then find the gradient of the line TM. Please find me the gradient, so small m of TM. Okay, pop your answer in the chat when you're ready. Yes, Funzo. No, sweetie. It's like, remember the midpoint is like, if I'm standing over here and that point over there is 10 kilometers away. If this is 0 kilometers, the midpoint of between 0 and 10 kilometers would be 5 kilometers, right? How did I get to 5 kilometers? I went 0 plus 10 divided by 2, and that gave me 5 kilometers. Okay, we're finding the midpoint. Right. The midpoint formula says plus, not minus. This is what happens when you're already done writing. Okay. It just shoops, goes out our brain. All right, let's talk about the gradient. Okay, the gradient of TM would then be, I'm just going to name this x1, y1, x2, y2. Right, so I'm going to get -1 minus 3 over 2 over 7 over 2. Oh, no, so no, look at me starting at the wrong place. 5 minus 7 over 2. All right. And I'm lazy because I don't want to figure out what -1 minus, it's a lot. I actually think it's -5 over 2 divided by, no, I'm going to punch it into a calculator. I'm being lazy. -1 minus 3 over 2 over 5 minus 7 over 2. And the answer I get out is -5 over 3. -5 over 3. Beautiful, Amber. Well done. All right. So -5 over 3. Now, I just want to remind you guys of something, right? I know that the gradient of this line that we've just found is -5 over 3. I also know that the gradient of QR is also -5 over 3. What does that tell me about the line QR and the line TM? Mathematically or analytical geometrically, that's not a word. I know I just made that up. Not that they're equal. What do we know about the two lines? Their gradients are equal. That means that the two lines are what? Who remembers? Yes, Funzo, correct. It means that our two lines are parallel, because when we have two gradients that are equal, then two gradients that are equal, then the two lines would be parallel. Well done. Okay, yes, correct. They decrease and they have parallel lines. No, you're absolutely correct, Pascal. They both decrease. You're 100% correct. That's why they're both negative, 100%. All right, give me a thumbs up. How do we feel about this question that we've just done? Are we all feeling okay? Beautiful. Excellent, excellent, excellent. Okay, here's your next task. Again, let's make this a little bit smaller. Yeah. Okay, Anna, at least it gives you a reference, okay? You get a reference on what it is that you should be looking for. Okay, here's your next challenge, guys. Question 3. I am. And I would just like to point out, that if your teachers have given you these exact questions for your exam, then the joke is on them, because like, what must can to happen? What must can to happen? Because the question I gave you guys above, Samuel wrote that question in his last paper. So technically it's not my fault. It's your teacher's fault for not setting a new paper. It's not me. It's not me. Okay, let's get started on these questions. For the sake of time, we're going to do 3.1 and 3.2. Okay. And 3.3. Those are easy. All right, 3.2 is a little bit tricky. So if you don't quite know what to do with 3.2, please just do 3.1 and 3.2, 3.3. This one is a bit tricky, so we'll talk about it. All right, pop your favorite emoji in the chat. I'm going to give you guys 4 minutes, and then we'll discuss. All right, go for it. No, it's not that scary, Funzo. I'll show you exactly what to do. It's not even that deep, trust me. Three more minutes. True, very true, Funzo. Okay, all right, let's get into these questions before we run out of time, because it is quiz day. All right, okay, first one says, calculate the length of PQ, leave your answer in third form. I mean, at this point, we should know PQ is equal to the square root of, okay, I'm going to name this one x1, y1, x2, y2. All right, so x2 minus x1 will give me 4. I will teach Coco 7. How? 7 minus 6 all squared plus 4 minus 6 all squared, which is equal to the square root of 7 minus 6, that's 1, plus 1 squared is 1, plus negative 2 all squared is 4. 1 plus 4 is the square root of 5. All right, that's 3.1, done. All right, I'm going to skip 3.2, I'm coming back. Let's go to 3.3, because that one is easier. Now it says, if the coordinates of S are 1, 1, show that PR is equal to QS. So if this is 1, 1, the only way we can prove that PR and QS are equal is to calculate for the distances, right? So I'm going to calculate for the distance of PR. So PR, we already know what QS is. So we just need to calculate for the distance of PR. And we need to make sure that it gives us root 5. Okay, so PR is going to equal to, I've already named that one x2 and y2, so I'll name this one x1, y1. So I'm going to have 7 minus 0 all squared plus 4 minus 3 all squared. Okay, which is equal to 7 minus 0 is Teacher Nels, did I miss something? PR and QS. The distance is not the same, right? Because that's 49 plus 1, which is the square root of 50. Right, this is root 50. They have the same midpoint. Yes, absolutely. But Pascal, mathematically speaking, logically speaking, whether you use the distance formula or the midpoint formula, you should get the same answer. Am I right, Teacher Nels? Yes?
Yeah.
Because distance and midpoint mean the same thing, especially in analytical geometry. I just think this question is rigged funny. It absolutely is rigged funny. Whoever did this didn't quite think it through, I don't think. Okay, all right, let's use the midpoint. Okay. All right. I know it should work. The distance of PR is equal to 7 plus 0 over 2 and 3 plus 4 over 2. 3 plus 4 over 2, which is indeed 7 over 2 and 7 over 2. There we go. Right. And then the midpoint of QS should also give us the same thing. So we should get 6 plus 1 over 2 and 6 plus 1 over 2, which is indeed correct. And that should give us 7 over 2 and 7 over 2. So rather than saying that they are equal to each other, I think what this question should have said is show that PR and QS bisect. That would have made so much more sense. Okay, so I think the wording is a little bit off there. Okay, because technically, if they have the same midpoint, they should have the same distance apart. Okay, I'm not 100% sure what happened there. I'm going to have to go ask my colleagues tomorrow, see what they think. All right, let's talk about 3.2 very quickly. All right, so 3.2 says, if T is the midpoint of QS, so we know that the midpoint between Q and S from there to there, the midpoint of that is 7 over 2 and 7 over 2, then determine the coordinates of S. Okay, so we know that if we use the midpoint formula, we should end up with the answer 7 over 2 and 7 over 2. So I know for my X values, I would get 6 plus whatever that value is divided by 2, and the answer I should get out is 7 over 2. So I should go 6 plus T over 2 is equal to, the answer I would get out for my X coordinate would be 7 over 2. Okay, same with my Y coordinates. If I went 6 plus that value, the answer I should get out is 7 over 2. So I can then say 6 plus K over 2 should give me 7 over 2. And then I can solve for both of these equations. I can solve for T in this equation, solve for K in that equation. So I'll then, yes, correct, times by 2 on both sides. Multiply by 2, multiply by 2, times 2, times 2. Those two will cancel, and those two will cancel. And then those two will cancel, and those two will cancel. So I'll end up with 6 plus T is equal to 7. And on this side, I'll end up with 6 plus K is equal to 7. And then I'm going to move 6's over to the other side. Therefore, T is equal to 7 minus 6, which is 1. And K will be 7 minus 6, which is also equal to 1.